Hello, my name is Gautam Krishna and I am presenting the final project for time series analysis on behalf of my group. In this project, we explore and forecast monthly global atmospheric CO2 concentrations. The dataset comes from NOAA and includes monthly global CO2 levels from 1979 to early 2025. The variable of interest is the average CO2 concentration measured in parts per million. This dataset is ideal for time series analysis because it shows a strong upward trend and recurring seasonal patterns. We can clearly see how the CO2 levels have steadily risen over time, which is important for environmental monitoring. To understand the underlying components of the series, we have used STL decomposition. The top panel shows the observed series. The second panel shows a clear long-term trend. The seasonal component, seen in the third panel, exhibits a consistent annual cycle. Finally, the residuals in the bottom panel shows irregularities not explained by the trend or seasonality. To ensure the series was stationary, we applied first order differencing to eliminate the long-term trend and seasonal differencing with a period of 12 to address the annual cycle. When reviewing the autocorrelation plots, the ACF showed strong spikes at seasonal lags, suggesting a need for a seasonal moving average term. The PACF, on the other hand, displayed a single sharp drop after lag 1, which indicated an AR1 component. We tested various combinations of seasonal and non-seasonal ARIMA models and compared their performance. SARIMA 111011 seasonal period 12 was selected based on diagnostic results, simplicity and interpretability. It captures both the short-term correlation and long-term seasonal structure in the data without overfitting. Most importantly, this model had the lowest AIC and BIC among reasonable alternatives and provided clean residuals, reinforcing its suitability for our dataset. This decision aligns with the theoretical expectations and ensures that the model is both statistically valid and practically effective for understanding the CO2 trends. When fitting the model, we found that the MA and seasonal MA terms were both statistically significant and contributed substantially to the model's performance. Although the AR1 term was not significant, it was retained to preserve model structure. The model's AIC and BIC values were lower than more complex alternatives, indicating a better fit with fewer parameters. After fitting the model, we assessed its validity using residual diagnostics. The residuals were centered around 0 with constant variance and no significant autocorrelation. The histogram indicated near normality and the Jung box test supported that the residuals behave like white noise. We concluded that all model assumptions were adequately met. In summary, our project demonstrates that the chosen SARIMA model effectively captures the underlying trend and seasonality in global CO2 levels. The model is statistically sound, interpretable, and passes all residual checks. Thank you.